introductory part, so kind of an overview of different side and waste streams that are or exist and are maybe used at the moment or probably potentially in the coming future. Also, the idea was to go through a little bit about the properties, maybe some problems or challenges and potential that is related to these different waste streams or side product streams as well. And on this course, the name says that waste to fuels, so we will kind of try to limit the processes that we focus on to such applications that end up with fuel products. And then also I was maybe glancing a little bit about these different generations of biofuels, so first, second, third, and so on. What is meant by those? Those were dealt in depth already, or in more in detail in that biofuel course. But this is just about the introduction about today, and we'll have some task also group work related to the different waste streams and waste to fuel, waste to energy applications or processes. So, but this is the order. I have changed the order a bit. So this ABC comes from the curriculum. So there will be not next time, but after that. So we'll focus a little bit on triglyceride waste processing. So different waste fats, different waste oils, and how those can be made into fuels. And those can, of course, be used in many ways, collected from many different sources. But what are the most prominent processes at the moment? So are these HVO and FAME, so fatty acid methyl ester products, which are kind of classical biodiesel, and then this HVO, so that comes from hydrogenated or hydrotreated vegetable oils. So those are kind of called also renewable diesel. So that's much more sophisticated product and process. The fatty acid methyl esters can be done very easily, and the processes are simpler than with this HVO. Also a little bit about the properties of these products. Third part of the course, not exactly in this order, so biomass conversion to biogas. So organic material can be converted into or digested into biogas, and that will be dealt to some extent in this part. So common processes, what pre-treatments are applied, something about the digestion and purification of the product gases, so storage and use of this biogas product. And I guess that's at this point enough. So enough of this content. Then fourth topic will be biomass residue and waste processing. So what I mentioned about my colleague Antti, so we have agreed that he will keep at least this part of the course. So something about biomass pyrolysis and gasification. And you'll hear this later on in some 1 month or so. Last part, second last part, or in the curriculum, is the plastic waste processing. That's something that I have been dealing quite a lot in the last recent years in different projects. So we'll take a look at already or start already today, partly this part with some introduction to mechanical recycling methods and such kind of things. Also, I'll introduce you the pre-study task for next time related to the plastic waste processing, and basically only some of these plastic recycling processes result in a fuel type hydrocarbon products. So mainly those different chemical recycling processes are potential for producing fuel components, but we'll take a look at that in the coming lectures and partly also today. The last, so we have 6 parts from A to F, and last is the future of waste streams. So there you'll get to know something about circular economy and perhaps these new or emerging waste streams and materials. And so basically cutting down fossil-based energy and products derived from fossil sources, and there are several alternatives. So in order to compensate these huge volumes from fossil-based industry, so we need to utilize these small, all available smaller streams of material to compensate the huge demand and consumption. And one part of this is this current course, so how to utilize more efficiently different types of waste materials and convert those into, in general, to energy, but more in this course, how to make some kind of fuels out from these waste streams. So, and always when we talk about fuels, so just a reminder about the legislation and importance of standards and standardization. So EU has set the fuel quality directive, and there are certain requirements regarding the fuel quality so that it's basically standardized uniform quality. You can use that same fuel in different countries, in different cars and so on. You don't need to worry about that there is too much or too little of some components and your engine will break, or your exhaust gas after treatment unit will break and so on. So this is the fuel quality, the composition, which type of components it contains, how much or how little. So that is controlled by fuel quality directive and standardized. So, and if we make fuels out from waste, so that has to comply with these directives as well. So I think here is not much new in terms of just the road transport. So majority of fuels are, as you know, diesel, gasoline, and then blended bio components in these fuels. So basically waste to fuels, or waste can be converted into diesel, gasoline components that can be blended then into these fuels. Also, natural gas and biogas vehicles are available and are used in Europe, so that makes sense to make biogas and liquefy it or compress it into LNG or CNG and use it in transport applications. So there we see also connection into the application side in the coming lectures. I think, okay, so here is just about the different types of fuels, are their share, or how what's the use percentage, and also some of the biocomponents here, but also the level of biocomponents is set by this fuel quality directive. So they set the minimum and maximum limits for certain biocomponents for example, in gasoline and in diesel. I think this is not maybe, I don't know, probably you are well aware of a gasoline, what it is. And just a reminder, chemistry-wise, so it's not a chemical or molecule, it's a mixture of several hundred of different organic and inorganic components. So it's not like water or ethanol, which are molecules and chemical components, but it's mixture of different hydrocarbons. The same applies to diesel. So it has a different composition, but it's a complex mixture of various organic molecules. And it can be that we can convert from our waste stream to some of the components that are suitable for gasoline or diesel, but we cannot usually convert waste directly into diesel or directly into gasoline. So because of this, that these are complex mixtures, and they also contain additives and some other components that, let's say, improve combustion performance, help lubrication, and many other beneficial effects. Aviation, okay, so there are also these liquid fuels that have been mentioned already, and there also several standards apply so that the compositions are standardized and their properties, so that these work one in different jets or airplanes without problem. So, but that's maybe it's the same that in the road transport area. In shipping, we also have fuels that can be made from waste streams, but in shipping it's a bit different. There, let's say, poor lower quality hydrocarbon fuels can be used, so the engines are more tolerant. Also, there are certain alternative fuels which are not that often used in aviation or road transport, and some mentioned here, like the liquefied LNG, also hydrogen, ammonia, methanol, as such, can be used in ships' engines. Here, something, just one or two slides about sustainability at this point of the course. So some time ago, like 20 years ago, when we started to have this biofuels as a trend, so then the first biofuels like bioethanol and biodiesel were made from edible components. So like vegetable oils and sugar sources that could be edible. And those type of fuels are called these first generation biofuels. And here you'll see certain advantages and disadvantages that apply to these first generation biofuels. So basically production and processing can be simple, but the drawbacks are, of course, that this are food components, and it's maybe not justified to convert edible material or food into fuel. Also, this has negative effects on land use and fresh water use. So therefore, there has been long already trend towards this higher second gen, trend out from these first generation biofuels. And there comes the role of these different waste streams. So already here, so whatever side streams come from different industries, so those basically can be converted to various techniques into useful fuel components. Typically, these side streams and waste streams are a little bit more complicated to process because of many factors, and that's something that we'll take a look at during this course as well. So and then there are more advanced biofuels or fuels also listed here, but these are, let's say, not part of this course. Here's like direct capture of carbon dioxide and many other things that are maybe not dealt during the course. But basically, if we convert waste into fuels, so it's somewhat progress. So we can talk about second generation fuels in that sense. So we are not competing with food production. We are not competing with fresh water use. So those are the good beneficial points of this approach. Also, of course, we prevent generation of waste. So it's like material efficiency, use materials more efficiently, or I don't know if you are aware of this waste frame directive or waste hierarchy, but again, EU, like how EU is guiding citizens and companies and things. So it's by making legislation or directives that set certain limits or boundaries how to operate, which are preferred ways of doing and which are should be avoided. So also in this waste sector, so there is a waste frame directive which sets certain limits and recommendations related to how to use waste streams. And if we generally talk about some product or material that is waste, so this waste hierarchy tells that what are the primary measures. So first of all, we should, let's say, prevent production of waste. So maybe use the product longer or repair it instead of throwing it into garbage. And then here is also preparing the waste for reuse. So it can be reused for something, or some parts of it can be reused. And that's more or the second alternative. Then if it's not reusable again, so one should try to recycle the materials in that waste. And that is basically part of what we are doing when we convert waste into fuels. So we are kind of recycling some parts of that waste into products or fuels. But typically these steps, prevention, reuse, recycling, are not enough, and quite a lot of, at least in Finland. So if we talk about this municipal waste, so it goes into waste incineration plants, and we recover heat and power, or heat and electricity out from. So the waste is burned and the energy is recovered. So this is the recovery stage. And what is done also, not in European countries so much, but in certain other parts of the globe, is that it's disposed in the landfill. And that is the least favored option how to treat waste. So then it's basically lost resource. So if you dispose it in landfill, so it's not beneficial to anybody in any way anymore. But basically, when we convert waste into products, so we are working somewhere in this borderline of recovery and recycling. So okay, so here was the same picture, a bit larger. Then during the course, so we'll take a look at some examples and ways how to convert waste into fuels. So generally, making of these fossil-based fuels, so it's very large-scale bulk production. So there, the production volumes are millions of tons per year level. So it's really large volumes and low profit margins and so on. So there, let's say if we replace some of the fossil-based feedstocks with waste streams, so in any case, so we probably are not producing very large volumes, but it's a step forward. So, but just the picture is showing that it's really this large-scale industry. So it's not something that you do in your backyard and to get the feeling of the production volumes or scale of manufacturing. These things to consider are something that are linked to the course topic, waste to fuels. And these slides, the idea was to just to give you kind of a broader overview of the energy and fuel production, and maybe to see what is the place for these different waste streams in this bigger picture. So there is what is like currently there is trends to increase the share of renewables and cut down the fossil fuels. And I think the use of waste streams is partly promoting both. But like said, so waste can also be fossil based. So if it's plastic waste, it's typically made from fossil based raw materials. So if we convert that to fuels, so then we are on this on dealing with fossil based materials. Also, like it's good maybe to consider that what are the applications of these fuels and how these compete or replace some of these fossil based major alternatives. So what the waste materials can actually replace, how large percentage, and what is the significance of those? Also, more general question to consider is also that why nowadays the fossil fuels are so much in use? Why they basically the whole modern industrial way of living is a lot based on fossil crude oil, coal, natural gas, and the volumes are really difficult to imagine. So those are very difficult to replace with anything. And there are these well-known problems, of course, behind the fossil fuel, fossil-based material use, and I think there is no need to go back at the moment to those. Also, the waste-based, side stream-based fuels, so there are certain problems that they don't solve, certain problems those solve, and think about which, for what problem this waste to fuels is a solution, and for what it's maybe not, and so this kind of considerations can be maybe done. But that's like basically this introduction to the topic. So we as humans and citizens, so we generate a lot of waste nowadays. So in principle, there's a huge amount of municipal waste, industrial waste, and so on being generated, being treated. Some of it is reused, some of it is burnt, used for production of energy, and so on. So there are, in any case, large volumes of material available that could be used for making of fuels, making of energy, and so on.